Students, in this session, let we consider the shortcut trick for the purpose of finding the integrals with respect to the integration by parts. So this shortcut method we called as tabular method. What we called tabular method. Or it can also be called as Hindu method. Or it can also be called as differential integral method, that is DI method. Now I had to consider one of the example now. So take integral of x square into cos 3x with respect to x. So for this example I call it as works at perfectly. What I call it as works at perfectly. I give the reason why it may be called as works at perfectly. So first try to write the two columns. One as what? D for the differential, that is for the derivative, and other for the integral I. The first function according to ILIT you always choose as what? The differential function, that is we take it as what? X square. And second function is what? Cos 3x. First we have to differentiate the x square, then what we have? That is 2x. Again differentiate 2x, what we have? 2. Derivative x is what? 1. Again differentiate 2, what we have? 0. Okay, further is not possible to proceeding to differentiate. Okay, that's why we get the end product as 0. So stop the differentiate, that's why it may be called as what? Works at perfectly. Now to consider the cos 3x. So I integrate this one. For integral cos 3x, that is sin 3x divided by 3, that is 1 by 3. So keep 1 by 3 as it is. Again integrate sin 3x, what we have? Minus cos 3x by 3. Then what we have? Minus 1 by 3 into 1 by 3 is what? 1 by 9 into cos 3x. Again integrate cos 3x, what we have? That is minus 1 by 9 into 1 by 3, that is 1 by 27 into sin 3x. Then we have to mark it now as a diagonal. So before that you have to write the convention. This is a plus, this is minus, this is the plus, this is minus. Then I have to mark the diagonals. Then these two I have to consider, these two I have to consider, these two I have to consider. Okay student, then you have to consider the integral. Therefore the integral is what? Integral of x squared into cos 3x with respect to x. Then write it now. So plus into plus is what? Plus. Then what we have? X square by 3 into sin 3x. Then again we consider these two. Minus into minus what? Plus 2x by 9. 2x by 9 into cos 3x. Again these two. Plus into minus is what? Minus 2 divided by 27 into sine 3x plus integral constant. So we got the integral. So this method what we call DI method or tabular method. Okay student, now consider one more example now. Example 2. So take it as what? Integral of e to the power of 2x into cos x with respect to x. Students, I here given one of the instruction. So that instruction is what? Stop the process when you got the matching term. You got a matching term. Okay. Now again we have to consider DI method. No, so we have to construct the two columns here as for the derivative and for the integral. So first function you take it as what? E to the power 2x and cos x. Then we have to differentiate e to the power 2x. What we have, that is 2 into e to the power of 2x. Again I have to differentiate what we have, that is 4 into e to the power of 2x. So we have to proceed the term, you won't get the 0 here. So we have to stop here. Now I have to find the integral, because once we got the matching term as e power 2x into cos x, I have to stop the process. Then what is the integral of the cos x? We know that sin x. What is the integral of sin x? Minus cos x, isn't it? Just analyze here. Your e power 2x cos x, e power 2x cos x, we got the matching term. Then you have to stop the process and you have to integrating backwards. Integrating what? The backwards. The similar process we have to consider here. So first you have to write the diagonals like this, and then you have to integrating backwards. Then what we have? So integral of e to the power of 2x into cos x with respect to x is given by, now write it now. So what do I write it? E to the power of 2x, e to the power of 2x into sin x. So before that you have to mark the sign. So for the first, plus minus plus, plus into plus is what? Plus e power 2x into sin x. Then minus into minus what? The plus. Plus. So 2 into e to the power of 2x into cos x. Now we have to integrating backwards. Now consider what we have. Plus into minus is what? Minus. Integral of 4 into e to the power of 2x into cos x, isn't it? Then e to the power of 2x into cos x with respect to x must be equal to e to the power of 2x into sin x plus 2 into e to the power of 2x into cos x minus, take the constant term, that is 4 outside from the integral. Then what we have? Minus 4 into integral of e to the power of 2x into cos x with respect to x. Okay, then what we have to do? We have to add, that is 4 into integral of e power of 2x into cos x on both sides. Then right hand side what we have? That is integral of e to the power of 2x into cos x with respect to x plus add 4 times of integral of e to the power of 2x into cos x with respect to x. Right hand side is what? E to the power of 2x into sin x plus 2 into e to the power of 2x into cos x. Okay, so plus 4 integral of e power 2x into cos x and minus 4 into integral of e power 2x into cos x get cancelled with each other. Then what we have? That is 4 plus 1 what? 5 times of integral of e to the power of 2x into cos x with respect to x must be equals to what? E to the power of 2x into sin x plus 2 into e to the power of 2x into cos x. Then what we need? This integral, isn't it? Therefore, the required integral is given by what? That is integral of e to the power of 2x into cos x with respect to x must be equal to e to the power of 2x divided by 5, that is dividing on both sides by 5, plus 2 into e to the power of 2x divided by 5 into cos x, here sin x, plus c. So which is the required integral. Now consider one more example. Example 3. So take the integral is what? X to the power of 3 into log x base c, that is natural logarithm dx. Now I give the method as, that is stop when it starts to get smaller. So this restrictions you have to keep in the mind. I got it. Again you have to consider di column here, that is d and I. For the d I have to use the function. We know that according to highlight we have to consider log x and x cube. Now consider here. So differentiate log x. Then what we have? 1 by x. Again differentiate 1 by x. What we have? Minus 1 by x square. The value of 1 by x square is less than that of the 1 by x. Now we have to stop this differentiation because we get the smaller value than that of the given function 1 by x, isn't it? Then you stop it, and then you have to find the integral of x cube. So what we have, that is x to the power of 4 divided by 4. Again differentiate x to the power of 4. Okay, is smaller. No, you stop it now. So we have to integrate backwards. Then what we have to do, we have to consider diagonal. A smaller, stop it. No, then we have to consider once again the sign, that is a plus, it is a minus. Again plus into minus is what? The minus only. So if you never get the 0, isn't it? You never get the 0. Now what we have to write it? That is integral we need, no? That is integral of x to the power of 3 into log x base c with respect to x. Then you have to write it now. So what we have, that is x to the power of 4 into log x base c divided by 4. Then what we have, minus sign, keep the minus, and to integrate backwards. Then what we have again, now consider, that is x to the power of 4 by 4 x to the power of 4 by 4 into 1 by x, 1 by x. Okay, with respect to what? X. Then integrate now. Then x to the power of 4 into log x base c divided by 4. 1 by 4 is constant into integral of what? X to the power of 3 with respect to x. Then what we have? So x to the power of 4 into log x base c divided by 4 minus 1 by 16 into x to the power of 4 plus integral constant. So this is the way I have to find the integral by using the integration by parts, by using the shortcut method, what we call it as, that is a Hindu method or maybe tabular method, or it can also be called as what? DI method. Okay students, now I can see one more example now. Example 4. We consider the integral is what? E to the power of x into cos x with respect to x. Now here I give the method. We have to stop. When you have to stop? When it starts to repeat. Repeat. Okay, at the time you should get a matching term. So this thing you have to keep in the mind, student. Now again we have to consider two columns as D and I. So take it as what? E power x in the D column, and integral column is what? The cos x. Then you have to integrate e power x is what? E to the power of x. Again integrate e power x is what? E to the power of x. Okay, but we get the terms are repeating here. Okay, then I have to stop the differentiation here with respect to the first column. Then I have to integrate the cos x in the second column. What we have? Sin x. Integral of cos x is what? Sin x. I integrate sin x, what we have? Minus cos x. So e power x into cos x, e power x into cos, we get the matching term. So we stop the process and then I have to repeat the integrating by, that is backward, integrating backwards. Okay, then write the sign convention. First positive, negative, positive, and write the diagonal. Then what we have? Therefore integral of e to the power of x into cos x with respect to x. What we have? E power x into plus what? Plus. So e to the power of x into sin x. Again minus what? Plus e to the power of x into what? The cos x. Then to repeat the nothing but I have to integrating backwards. Then what we have? So plus into minus what? Minus. So e to the power of x into cos x. So therefore we had adding into e power x into cos x on both sides. Then what we have? That is 2 times of integral of e to the power of x into cos x with respect to x must be equal to e to the power of x into sin x plus e to the power of x into cos x. Then we got the integral that is given by integral of e power x into cos x, that must be equals to, take e power x as a common factor and dividing by 2 into what? That is sin x plus cos x plus integral constant. So this is the way, student, we have to find the integral when the integrand contains the product of the two functions. That is, we have to integrating by parts. So integrating by parts is a tedious process. That's why we have to use this shortcut method. That is what we call it as, that is DI method, or maybe tabular method, or maybe the Indo method.